Miss, Assalamu alaikum.
Walaikum assalam. How are you, Surya?
Alhamdulillah, Miss, how are you?
I'm also good. All right. Um, what we have to do? So we have to do something about periodic table. Okay. So the periodic table. Do you know what is the periodic table?
Miss, we discussed all this from the first month that we need a periodic table to do
Do you
chemistry,
know?
right?
Okay. Do you know what are atomic number and atomic masses?
Yeah, Miss, I know all this, but I need to just revise.
Okay. I mean, in periodic table, we have a lot of things to be discussed in periodic table, including, for example, um, I mean, we should discuss that periodic table there are something which is called atomic number, and this there is something which is called atomic mass. Other than this, we have one more type of thing. Yes, what happened when we are moving top to down, and what is there at the right side of the periodic table, and what is there at the left side of the periodic table. So basically, periodic table has a lot of detail. All right. I mean, you have to discuss periodic table in terms of atomic number, atomic mass, in terms of metals and the non-metals. And other than this, there is one more thing, and that is called, other than this, let me check. Yes, the transition elements. Do you know about the transition elements?
Yeah, Miss, I know, but right now I can't remember it.
Oh, okay. You need a revision. So, okay, let me tell you what is periodic table. I mean, the periodic table is basically okay. So the periodic table is something where we have arranged elements in a specific manner. Means, for example, there is sodium, magnesium. I mean, we have discovered so many elements, and they are not. I mean, all are not organized before. I mean, periodic table is something in which we have organized all the elements in a specific order. So basically, periodic table is, wait, for example, in periodic table, we have something which is called group, and we have something which is called periods. Do you know what is the difference between groups and the periods?
Uh, like groups are
We have,
there are like 8 groups, and period are no, I don't
hmm,
know the period, but I know the groups.
um, okay, what are groups? I mean, rows, and a periodic table has two things, the rows and the column. What do you think? What is period and what is group?
The rows are the groups.
Rows. Rows are the groups. So these are
Like
the rows. These left to right. Left to right is called row.
there are total 8 groups, right? The up to
Hmm.
down, like that.
Okay. So basically, wait. If you are reading periodic table top to bottom, it means you are reading groups. This is group. If you are reading periodic table from left to right, means you are reading period. Is it clear to you?
Yeah.
This is the difference between group and the period. I mean, if you are reading periodic table from left to right, it means you are reading period. Or if you are reading a periodic table top to bottom, it means you are reading groups. So this is all. I mean, this is the basic of the periodic table. Okay, now let me discuss you one thing. Um, wait. I mean, you can see the periodic table, which is already given in your book or of A levels and the O levels both. You can see a different books, or you can see the Google. So the periodic table, let me show you. There is left side of the periodic table, which contain metals. And these metals are highly reactive metals. This is the left side of the periodic table. They are, I mean, they are highly reactive metals. What is periodic table? Periodic table is just like a shelf in which we have arranged elements in a specific order. And a periodic table is divided into metals, non-metals, and the transition metals. So left side of the periodic table consists of metals, and they are reactive metals. They are highly reactive metals like sodium, potassium, magnesium, calcium. These are the metals which are present at the left side of the periodic table. Other side of the periodic table is the right side of the periodic table, which include group 4, 5, 6, 7, 8. Let me show you. This is the right side of the periodic table, and it contains non-metals like carbon, like silicon, like nitrogen, oxygen, chlorine, fluorine, argon, helium. These are the elements which are present at the right side of the periodic table. And the middle of the periodic table, the middle of the periodic table is called transition elements. They are also metals. I mean, the left side of the periodic table is metal. The center, the middle part of the periodic table is also metal. Then what is the difference? I mean, what is the difference between these two metals? The left side of the periodic table contain highly reactive metals. They are highly reactive metals. They are more reactive. And the middle part of the periodic table contain transition elements, transition metals. What are transition metals? They are also metals, but they are not that much reactive like sodium and the potassium, which are there at the left side of the periodic table. So the metals which are present in the center of the periodic table, they are not that much reactive, but yes, they are wait, why we have separated them? Because they have different type of valency. They shows different valency. The first difference is they are not that much reactive. I mean, they are less reactive as compared to the metals which are present at the left side of the periodic table. And other than this, basically these middle elements which are transition metals, they are having variable valency, different valency. What is valency? Valency basically is something which decide the feature of the element. Like valency will tell you the feature of the element. Um I mean, valency will decide, for example, sodium, group 1. It has +1 valency. What does it mean? It means it means sodium will donate electron and it will become positive ion. So this +1 is the valency of the sodium, which is telling the future of the sodium actually. Is it clear?
Yeah, miss. Miss, the thing is,
Mhm.
so do we need all, like we have like so many topics left. So periodic table, all this, or we need to do like so many other things. We need to know about periodic
Periodic
table.
table, no, periodic table is something which is considered as the backbone of the chemistry. This is the base of the chemistry. This is considered as a backbone of the chemistry. So periodic table contain, let me tell you, periodic table contain metals, non-metals, other than this, transition metals. Then we have to discuss how metals are different as compared to transition metals. Then we have to discuss how metals are different from the non-metals. What is the major difference and what is the similarity? What is the dissimilarity? Other than this, we should know what is valency. Then we should know what is charge. Then we should know what is oxidation state. Then we should know what groups are telling you. What are the the elements which belong to group 1? What are the properties of those elements?
Uh,
Then we should
can you
know the
explain charge?
yes,
Can you explain that?
charge.
Charge. Yeah.
Charge is simple. Actually, the thing is valency. Let me tell you, charge. What is charge? For example, if there is sodium, if I say sodium has +1 charge, so it means sodium has donated its electron. I mean, every atom has equal number of protons and the electron. Every element has equal number of proton and electron, so that charges could be balanced. I mean, every electron carry negative charge, every proton carry positive charge. So number of electrons and number of protons should be same, so that every positive charge can cancel every negative charge, and the element could be neutral. So basically, if sodium has +1 charge, it means it has donated one electron. I mean, it is an ion now. It has done something like bonding. It has donated one electron. But if I say, no, this is not a charge, this is the valency. I mean, if I say sodium has a plus one valency, it means it it is not donating its electron right now. It is neutral right now. This plus one is the future of the sodium, means when it will make a bond, it will get plus one. So charge and the valency both are totally different. Charge means charge is something like past. Sodium, if I say sodium has a positive charge, it means sodium has done something in a past. I mean, sodium has donated its electron in past. But if I say no, this is not a charge, this is a valency, it means sodium has not donated any electron right now. It will donate electron in future. I mean, whenever sodium will make a bond, it will donate one electron. So valency and charge both are both are quite similar, but there is little difference. So basically, charge means charge means sodium has done something in a past, means sodium has donated its electron in past. But if I say no, this is the valency. So valency means sodium will donate electron in future. So valency tells you the future of the element, that how it will react. It will react by becoming positive ion, or it will gain electron during reaction, or it will donate electron during reaction. So basically, charge and the valency, they are quite similar, but charge means sodium has done something in a past, and valency means sodium will do something in a future. I mean, sodium has donated one electron, means sodium will get plus one charge. If sodium will donate electron in future during the reactions, mean it will get charge. So right now the plus one is valency, that is not a charge. Charge will appear when something has gained or donated electron. For example, chlorine negative. If I say Cl minus, this minus sign is a charge. If there is nothing, it means there is one. No? So if I say chlorine has minus one charge, what does it mean? It means it has gained one electron in past. That's why it has charge right now. But if I say no, chlorine is neutral right now, it has minus one valency. This is not the charge, this is the valency of the chlorine. It means it will gain electron in future when it will react. This is the major difference between valency and the charge. I mean, 99% the charge and the valency both are the same thing. I mean, if I say that this is a sodium, it will become positive ion. It means this is the valency of the sodium. So when it will react, it will become positive ion, means it will gain a positive charge by donating electron. So see, the valency and the charge both are the same thing. So valency is something which tell you the future of the element, that what charge will be gained by the element. Yes, is that clear?
Yes.
There are three terms basically. Number one, valency. Number two, charge. Number three, oxidation state. Sometimes these three are same. Sometimes they can be different. For example, if I say this is a sodium and it has plus one charge, this is a charge. It means sodium is not neutral. Sodium is not neutral. Sodium has donated its electron to someone. So this is a charge now. So this is telling you about the past of sodium. I mean, this positive one is telling you that sodium has donated its electron in its past. But if I say no, this plus one is the valency, it means sodium is neutral right now. It has all electron, which are the part of the sodium. It hasn't gained or donated any electron, because this one plus one is the valency, means it is telling you the future of the sodium, means whenever sodium will react, it will become plus one charge. So valency and the charge, they are they are same most of the time. Or if I say that this plus one is not charged, it means it hasn't done anything in the past. Or if I say this plus one is not the valency, it means it is not telling you the future of the sodium. But if I say this plus one It's not charge, not valency, but this is oxidation state. This is oxidation state. What does it mean? Oxidation state? It means whenever sodium, or you can say oxidation state is something which tell you about the present of the element. Valency, future, charge, past, oxidation state, present. So if I say this plus one is the oxidation state of the sodium, it means sodium is becoming plus one ion right now. It means sodium is donating electron right now. It has not donated electron in past. It will not donate electron in future. It is donating electron right now. For example, if I say Cl negative, and this negative one is the oxidation state of the chlorine. It means chlorine is gaining electron right now. It is gaining one electron right now. So oxidation state, valency, and charge all are the same thing. I mean, they are nearly same. They can be different in some cases, but right now we are discussing the basics. So in basics, they are the same. So valency, future, oxidation state, present, and charge is telling you about the past of the element. This is the major differences between these three things. And the whole chemistry is based on oxidation state and the charge and the valency. You should know the valency of every element, then you should know what charge of element and why there is a positive and negative charge on the element. Then you should know what is the oxidation state of element right now. Is it clear?
Yeah, miss.
The other thing, I mean, you should know the basic issue with the periodic table. The basic issue with the periodic table is hydrogen. The basic issue with the periodic table is for the hydrogen. I mean, hydrogen doesn't belong to any group. We don't have any group of the hydrogen. Let me tell you, I mean, periodic table contain groups. Groups means top to bottom. Top to bottom, I mean, you are coming top to bottom. So these columns are called groups. So if I say I have studying the group 1, so all the elements like element 1, element 2, element 3, element 4, or you can consider the elements of group 1 like sodium, potassium, and so on. So all the elements which belong to the same group, they have same chemical properties, and they have same they have few similar physical properties also. So basically all the elements which belong to the same group, they have similar properties. So if I say that sodium and potassium both belong to group 1, it means both are same, both are solid, both are highly reactive, and they belong to group 1. So let me tell you, groups tell you about the number of valence electron. So if I say that there is any X element and it belongs to group 7, it means it has 7 valence electron. If I say I have, for example, silicon, and if I tell you that silicon belongs to group 4, what does it mean? It has 4 valence electron. If I say that I have carbon, it belongs to group 4, it means it has 4 valence electron. Valence electron means the electrons which are present in the last shell. So basically, for example, if I say I have a bromine, and if I say it belongs to 7 group, it means it has 7 valence electron. Valence electron means the elements which are present in the last shell, in the outermost shell. So group number tells you about the number of valence electron. This is the basic of, I mean, this is the basic of the periodic table, and periodic table is the backbone of the chemistry. If you cannot understand the periodic table in detail, none of the chapter can be understood by you. So for example, if I say I have aluminum and that belongs to group 3, it means it has 3 valence electron, not the inner electron, the valence electron. The outermost electrons are 3. For example, if I say I have magnesium and it belongs to group 2, it means it has 2 outermost electron. Argon, group 8, means 8 outermost electron, 8 valence electron. Okay, so see what group is telling you. Group is telling you about the number of valence electron, but group will not tell you about the number of valence electron all the time. I mean, group 1. Group 1 means highly reactive element. For example, group 7. Group 7 means the element which has 7 valence electron, and group 7 means halogens. Halogens, halo is a Greek word. Halo means salt. It means any element which belong to group 7, it has 7 valence electron, but it also have it also has ability to make a salt. Group 7 means halogens. All the elements which belong to group 7, they will make a salt. Like chlorine, it will make a salt. Bromine, it will make a salt. Fluorine, it will make a salt. Like sodium fluoride, sodium chloride, potassium bromide, iodine, it will make a salt. So all the elements which belong to group 7, they will make a salt. For example, if I say group 8, so all the elements which belong to group 8, they have 8 valence electron. And other than this, all the elements which belong to group 8, they are inert. Inert means unreactive. None of the elements which belong to group 8 that will react. No, it will not react. Any element which belong to group 8 that will never ever react. That's what you should know for the groups. So groups will tell you about the number of valence electron, and other than this, group will also tell you about uh, few properties. So any element, for example, if you have 6 elements and all 6 belong to the same group, like group 8 or group 7 or group 1 or group 2, so they should have same chemical or same physical properties. They should be same. They should be identical to each other. And the period always tell you about number of shells. If I say that I have hydrogen, it belongs to first period. It means it has only one shell around it. If I say I have sulfur, and if I tell you that it belongs to third period, means sulfur belongs to third period. It means it has 3 shells around it. So period will tell you about the number of shells only. Period will tell you about the number of shells only. That's it. But the group can tell you about the number of valence electron. Group can tell you about the physical properties. Group can tell you about the chemical properties. Period is very simple. It will tell you about number of shells. If I say I have X element, it belongs to group 5. It means it has five shells. So if I say I have any X element, it belongs to group 2 and its period number is 3. What does it mean? Or what type of question could be there in exam? They can give you any element, they will tell you about its group and the period number, and then they will ask you that how many total electrons are there in that element. So you will never say it belongs to group 2, so it has 2 electron. No, 2 valence electron. What about inner electrons? So you have to see. I mean, it belongs to period 3. Okay, so this is a nucleus. Period 3 means it has 3 shells around it. So you have to make 3 shells. Group 2 means the valence electron are 2. So 1, 2. And you know very well, inner shells are already complete here. I mean, if inner shells are complete, that's why electrons are moving in the outer shell. Na? So, first shell can be filled with 2 electron only. Second shell can be filled 1, 2, 3, 4, 5, 6, 7, 8. In second shell, you have to fill 8 electrons all the time. Na? So now count the electrons. 1, 2, 8, 8 plus 2, 10, 11, 12. 12 electrons. See. So total 12 electrons are there. So this is how you have to um, count total electron. Or if they ask you that what is the nature of the X element, so it belongs to group 2. Group 2 is there at the left side of the periodic table. It is present at the left side of the periodic table, and all the elements which are present at the left side of the periodic table, they are highly reactive. Is it clear?
Yeah, miss. Yeah, miss.
Okay. Other than this, now the hydrogen. What is the group of hydrogen? This is the most repeated question in your past paper. They will ask you, what is the group of hydrogen? Hydrogen, hydrogen is the lightest and the simplest element. See, hydrogen. This is the nucleus of the hydrogen. The nucleus of the hydrogen contains 1 proton only. There is no neutron in the hydrogen. And there is only 1 shell around the hydrogen. This is the 1 shell. And this has only 1 electron. 1 electron. Let's make 1 electron. Yes, this is hydrogen. So the question which is very common in your exam is, what is the group of hydrogen? Okay. First, discuss the period of the hydrogen. Hydrogen has only one shell around it, and period always tell you about the number of shells. So it has only one shell. So hydrogen belongs to first period. Okay. So the period issue is solved. What about group? Hydrogen. So most of the students say, Miss, hydrogen belongs to group one. Why hydrogen belongs to group 1? Because it has one valence electron. We have already discussed that any element which belong to group 1 that has one valence electron, like sodium had one valence electron, other than a potassium. Potassium has one valence electron. So all the elements which belong to group 1, they have one valence electron. So students say that, Miss, we can put hydrogen into group 1 because it has one valence electron. But no, wait, group group doesn't tell you about all. I mean, group will never tell you about only number of valence electrons. The properties should be the same. So see, sodium and potassium, they are highly reactive. Hydrogen is not reactive. Okay, this similarity. Other than this, sodium and potassium, they are solid at room temperature. Hydrogen is gas at room temperature. Okay. Sodium and potassium, they are metals, highly reactive metal. Hydrogen is non-metal. I mean, there are a lot of dissimilarity. There is only one similarity, that hydrogen contain one valence electron, and group one elements also contain one valence electron. So if you're putting any element into the group, so some properties should be the same, and all the properties are totally different. Group one elements means they are metals, they are highly reactive, they are solid at room temperature. But hydrogen is non-metal, that is not reactive, that is gas at room temperature. It means, and one thing more, the elements which belong to group 1, they are electropositive. Electropositive means they will donate electron all the time. They will lose electron all the time. Hydrogen, it will never lose electron. It will share electron. So there are a lot of dissimilarities. It means we cannot put hydrogen in group 1. So hydrogen cannot, I mean, you cannot put hydrogen in group 1. It means hydrogen doesn't belong to group 1. Then what is the group number of the hydrogen? Okay, so most of the students say, Miss, we can put hydrogen in group 4. Why? Because hydrogen is non-metal now, so group 4 is also non-metal. Okay, but hydrogen, you can see there is only one shell around the hydrogen, the first shell, and first shell can be filled with two electron only. But hydrogen has only one electron. It means hydrogen has half filled shell. It should have two electron in the shell, but it has only one electron. It means it is half filled. Okay. So group 4 elements have 4 valence electron. They need 4 more electron to complete the shell. It means it means group it means group 4 elements have half filled shell. So basically, hydrogen and the group 4 element has one similarity, that they have half filled shell. And there is one more similarity. Both are non-metal, but we have a lot of dissimilarities. I mean, hydrogen has one electron, group 4 have 4 electrons. Hydrogen need one electron to complete the valence shell. Group 4 elements need 4 electrons to complete the shell. Hydrogen is gas at room temperature, while group 4 elements are solid at room temperature, like carbon and silicon. So we cannot put hydrogen in group 4. This is your past paper question. They can ask you why we cannot put hydrogen in group 4, or why hydrogen doesn't belong to group 1, why hydrogen is not suitable in group 7. There are, I mean, most of the students say, Miss, we can put hydrogen in group 7. This is also your past paper question. They will ask you why we can, I mean, what is the similarity between hydrogen and group 7? And if there is any similarity, then why we are not putting hydrogen in group 7? So see, hydrogen has only one electron. Group 7 elements has 7 electrons, like chlorine, bromine, fluorine. Other than this, hydrogen need only one electron to complete the valence shell, because it has only one shell. And group 7 elements have 7 valence electrons. They need only one electron to complete the valence shell. This is the similarity. This is similarity. Hydrogen need one electron to complete shell. Group 7 elements, they also need one electron to complete the shell. Other than this, yes, hydrogen is gas at room temperature. Group 7 elements are also gas, like fluorine and the chlorine, they are gas at room temperature. Okay. Then it means hydrogen belongs to group 7? No. there is some dissimilarity. Group 7 elements are highly electronegative. Electronegative means electron negativity is the ability of any element to attract the shared pair of electron. I mean, group 7 elements can attract electron toward themselves, but hydrogen cannot attract electron. Hydrogen is not electronegative. And group 7 elements can gain electron. Hydrogen cannot gain electron. Group 7 elements are making salts. Hydrogen is not making salt. Group 7 elements are making the compounds which are called halides. That is the topic of upcoming chapter. But hydrogen is not making halide, it is making hydride. So there are a lot of dissimilarities between hydrogen and group 7. So the possibility for the hydrogen is we can put hydrogen in group 1 or we can put hydrogen in group 4, or hydrogen is having little similarity with group 7. But hydrogen has a lot of dissimilarities with group 1, with group 4, with group 7. It means hydrogen doesn't belong to group 1, group 4, group 7. That is why hydrogen belongs to period 1, means it has one shell around it, but hydrogen doesn't belong to any group. Hydrogen doesn't belong to any group, means there is no group of the hydrogen. So you can see the periodic table, hydrogen is placed on the top of the periodic table. You cannot see hydrogen in the column of any group, in group 1, group 4, group 7. No, it is placed on the top of the periodic table because it is not fit in any group. And your past paper question could be, why we have put hydrogen on the top of the periodic table. What is the reason behind it? And you should know the reason. So this is the reason. And the reason is hydrogen
Miss,